Action.
So, practice final 3, off we go. Page 1, you'll get a periodic table tomorrow because that's highly recommended, using column numbers to do things. So let me do symbols with charges first. Let me come down the right edge and then we'll double back and fill in the middle. So, periodic table one's first. Hydrogen, that is the top 2 blanks, go with an H plus and an H minus. It doesn't matter which one is in which blank, but H plus, H minus would be 1, 2. Skip 3 for a second, skip 4 for a second, let me go to 5. 5 would be an O with a 2 minus. Let me grab my chalk. Right or wrong?
Wrong.
Wrong. I don't know what you're talking about. That is correct. So we want to do, in the exponent position is where you want to put your charges. And I don't know why, but it's always 2 minus and not minus 2. So if you like writing minus 2, cut it out. But 2 minus up in the exponent zone and O for oxygen. The reason we know that is not because of memory, unless you memorized it by accident, which might have happened because we used oxygen like so many times, but because it's in column 6. So if it's in Roman numeral 6, the magic number of desirable electrons is always 8. So from 6 to 8, you need to add 2, and electrons have a charge that's negative, so that is a charge of -2. Skip 6, skip 7, go to 8. Nitrogen is a capital N, and it is in Roman numeral 5, so that needs to gain 3. So charge on that in the exponent position is 3 minus. Skip 9, go to 10. Phosphorus, same column, so P, and then 3 minus. Skip, skip. Chlorine is 13, so chlorine's in column 7, so the charge there is -1, but we don't write the 1. Just write Cl and put a minus in the charge phase there. Skip, 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 skip. 14, 15, 16, 17. We're down to 18-ish. Sulfur's in column 6, so capital S and then charge?
2 minus.
2 minus. 19, 20, 21, 22, 23, 24, 25. Lithium, I'm down to 26. Lithium is finally a little bit different. Lithium is in column 1, which means it has 1 electron, and it would rather give it away. So that has a charge of +1, but we don't write the 1. So just an Li, and then a plus in the exponent slot. Bromine is Br, column 7, so charge of minus. Skip 1. Magnesium's 29, so Mg. Mg's in column 2, so charge of 2 plus. Barium will do next, column 2, so Ba, 2 plus. Fluorine is an F, so we're back to column 17, 7, so charge -1, so just write a minus. Aluminum is in Roman numeral 3, so charge on aluminum is 3 plus. Potassium's a K, it's in column 1, so charge of plus. Skip, skip, skip. 6, I'm down to like 37. Cadmium is CD, that's in Roman numeral, where are you? There you are. It's in 2B, but it's still, that's enough to give you the charge of 2 plus. Strontium, Sr, is in 2A, so charge of 2 plus. Sodium is Na, that's in column 1, so charge plus. Iodine is an I, column 7A, so charge of minus. Calcium is Ca, so column 2, charge of 2 plus. Silver is Ag, column 1B, so charge of plus. Zinc, Zn, Roman numeral 2B, so 2 plus. And then I'll stop with the ones that the periodic table dominates it. Question about periodic table domination, how we use the periodic table to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21 giveaways from the periodic table. That should be 21 points. Something there. Okay, more giveaway points. Anything that's a negative charge has a name. You just make a name that ends in I. There's 9 easy money ones of that. So somewhere we'd have a hydride in number 1 or 2. Go down to 5 and oxygen becomes oxide. Go down to number 8, nitrogen is nitride. Go down to 10, phosphorus is phosphide. For 13, chlorine is chloride. Down to number 18, sulfur becomes sulfide. Bromine in 27 is bromide. Fluorine in 31 is fluoride. It's F-L-U-O. If you go F-L-O-U-R, that's flour. That's not what you want. Down to 40, iodide is a thing. And that's the easy 9. Question about the easy 9. Okay, then still periodic table, but there's a hard 5 that have like double names. So what's on the periodic table but has a double name?
Iron.
Iron is one. They have double name, double charges. One of the charges is always 2 plus. So you don't have to memorize 2 charges each time. You just have to memorize the other charge in addition to 2 plus. So iron, I'm looking at number 28. Iron, I'm going to use the periodic table maybe to help me on some of these, but iron, I'm not getting any help. Iron is 2 plus. Iron is also 3 plus. How do you do that? I don't know. You just memorize it. I don't have a good scheme for that. In terms of the name, you want to write out a bunch of stuff. So one thing you'd want to write is iron with a Roman numeral 2. Another part of this would be iron with a Roman numeral 3, where the Roman numerals just match the charges. And then iron is F-E-R-R stuff. And then it's a matter of remembering which prefix goes with the lower number. The lower number? Everybody have a firm memory?
Us.
O-U-S. O-U-S is the lower, I-C is the higher one. So for number 28, we're going iron 2 ferrous, iron 3 ferric, Fe2 plus versus Fe3 plus. What's another one that's a weird O? Tin. So tin is around number 34. Tin is SN. And for tin, let me see if the periodic table helps me. It does. Tin is in column 4. So in addition to SN2 plus, it's also SN4 plus, because the periodic table gives us the 4 and we just have to know that 2 is the choice. So the tin 2 is called stannous, S-T-A-N-N-O-U-S. Tin 4 is stannic, S-T-A-N-N-I-C. Another weird one. Copper. So copper, the periodic table helps us because copper's in Roman numeral 1b. So one of the charge options is a plus. And the other option is the 2 plus that they all have. So Cu plus and Cu2 plus, which makes it copper 1, which is cuprous, C-U-P-R-O-U-S, and copper 2 is cupric, C-U-P-R-I-C. Another one. Lead. Lead is number 44 on this. Lead, periodic table helps us. It's in column 4, so one of the charges is 4 plus. There's Pb2 plus, there's Pb4 plus. The lead Roman numeral 2 is plumbus, and the lead Roman numeral 4 is plumbic. And then our last one that's the weirdest of the weird is mercury. Mercury's Hg, it's 2 from the bottom, number 45. Mercury, Hg, the periodic table, I don't think helps us. Where are you, Mercury? There you are. It's in 2b, so we already knew it had a charge of 2, and now this is telling us it has a charge of 2. Well, guess what? That actually is helpful, because there's 2 of them that have a charge of 2. There's Hg2+, and there's Hg2+, where one of these has a little 2 subscript. So Hg2 with the 2+, and Hg with the 2+. Then in terms of the Roman numerals, if there's 2 of them that give you a 2+ total, they each gave you 1. So there's Mercury 1, which is Mercurus, and there's Mercury 2, which is Mercuric. And those were stinkers. Question about the stinkers. Then there's 21 to memorize. So you might want to make yourself like a little list of what the goals are here. What's the highest charge anybody has on the ones you have to memorize?
4.
No 4s.
3 plus, or 3.
There's a 3. There's a 3- charge. How many 3- chargers do you have on the memory grouping?
1.
Only one. Which one? What's the only one with a charge of 3-? It is phosphate. So look at number 9. Phosphate would be PO4 with a 3-. Be careful you don't get messy and write something like this, because I don't know what to do with that. Like 43 Palamalu or something. I'm not sure what's going on there. So we want to go PO, stash a 4 down low, put a 3- up top. I recognize for some handwriting styles, these spaces are a little bit tight. So maybe you want to do them like in a zigzag pattern or something to just create some space. If you have trouble vertically with the space I'm giving you, maybe you like space them into columns or something. But that's the only one with a 3- charge. 2 minuses. How many 2 minuses do you have?
6.
I couldn't resist myself. I was thinking the answer and held up the fingers, and you were looking at me. Score 1 for your tricks. There's 3. 3 pairs makes 6. So there's 2 that have to do with which element?
Nitrogen.
No, those are what?
Sulfite.
The sulfurs. The sulfurs have charges of 2. So anything, the sulfate, sulfite are going to be 2 charges in a second. Another pair, other than the sulfur pair? Chromium pair. There's a chromate, there's a dichromate. Those have charges of 2-. Then the other pair that have charge of 2-.
Oxygen.
Are the carbon things. Carbonate has a weird buddy. Carbonate's buddy is... no, there's not that.
What?
There's, when we go up in oxygen, like CO3 is a thing, and then the C2O4, what's that called?
Oxalate.
That's oxalate. It's a carbon-based thing, but it has a weird name. So that's the 6 that we need to hunt for the 2- charges. So let me hunt them. So let's do them in the order what people said them. So we said sulfurs first. So there's sulfite, there's sulfate, and then probably you heard the saying that's stupid from the book, but 8s are great. 8s are slight. You know, the 8s are the bigger number than the ites. The 8s are also usually 4s. Not all, but most of the 8s are in O4s, and that holds true here. So sulfate, which is number 21 for sulfate, is SO4 with a charge of 2-. So sulfite, which is up to number 19, that's SO3 with the 2-. Then we said chromium stuff. So let me go back up to number 12. Chromate is CrO4 with a 2-. Dichromate, di you know is a prefix that means
2.
2. So take your chromium numbers and almost double them, but not quite. It's not Cr2O8, it's Cr2O7, but close to double. So dichromate, which would be number 11, that's Cr2O7, charge 2-. Then we said carbonate. Carbonate's down to number 24. Carbonate would be CO3, 2 minus. And then who was carbonate's weird friend that has an extra oxygen? Oxalate. So that's up to number 4. It has an extra oxygen and an extra carbon. It's C2O4, 2 minus. I'm not going to do the -1 charges right now because there's a billion of them. Are there any positive charges in the memory group?
Whichever one's NH4 plus.
NH4 plus, yeah, which one is that?
Is that ammonia?
That is ammonium, not to be confused with ammonia, but ammonium. That's number 36. So ammonium is NH4 with a plus. That's the only one with a positive charge. So you might want to just memorize your counts or come up with a silly slogan or somehow just to know there's one of the 3 pluses, there's 6 of the, one of the 3 minuses, 6 of the 2 minuses, and they come in pairs, and then everybody else other than ammonium, which is the only positive one, is a -1 charge. Question on the ones that aren't -1 charges first? Yeah.
Can you repeat chromate?
Chromate was CrO4 with a 2 minus. Something there. Okay, so then let's just do the other ones. We didn't do yet 3 is hydroxide. That's OH with a minus. We didn't do nitrite and nitrate, and this is the one exception to my thing that I said the 8s usually have 4. Nitrate doesn't do a 4. Nitrate does a 3. So number 6 is NO2 with a minus. Number 7, nitrate, is NO3 with a minus. Phosphate, I did. The chlorines, just they count. So I'm at the 14, 15, 16, 17 zone. All of these chlors are ClOs with minuses. It's just a question of the amount of O's. The 8s are more than the ites, and the per means like it's even more of an 8. So the perchlorate, that's ClO4 with a minus. Regular chlorate is ClO3 with a minus. Regular chlorite is ClO2 with a minus. And the prefix hypo means there's even less than there was in the other one, so that's just ClO with a minus. Hydrogen sulfite is just like doing sulfite, just put an H in front of it. It's HSO3, and that's a minus because the hydrogen tinkers with the charge by 1. Hydrogen sulfate is HSO4 with a minus because the hydrogen tinkered with the charge again by 1. Hydrogen carbonate is just like carbonate, but hydrogen changes the charge by 1 again, so HCO3 minus. So that's another way you could help spot the 2 minuses. Anybody that buddies up with hydrogen, when it doesn't buddy up with hydrogen, is part of the 2 minus family. So that's another like giveaway fact. Cyanide is number 25, so that's a CN, both capital letters, and a minus. And then I think that's it. I think we got them all. No, that's a lie. Very, 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 very bottom one. Acetate is C2H3O2 with a minus. Hiding at the bottom. Ah, there's one hiding in the middle too. I didn't say 35. Permanganate is Mn, and that's O4 with a minus because the 8s usually have 4s. I did those in a weird order, but I did them the way my brain would do them if it were my test. I would do them in groups. That's a mere 61 points there. Something there? Yeah, sure. Anybody something on that? First time I taught chem, I read the book and it said you need to memorize those, and I thought, oh, they're kidding. I'm not going to memorize those. And then as I prepared that first year I did this class more and more and more through the book, I thought, they were not kidding. We do need to memorize these. And then I doubled back and made all these quizzes back in the chapter that was like 4 chapters in my rearview mirror in terms of prep that I hadn't taught the chapter yet to like make people memorize these. It was unavoidable. They spoke the truth when they said that. I was just as disappointed as you were to find out you had to memorize those. Something there. Alrighty, so stoichiometry. That's where I came on the scene. It's a measurement of the relative quantities of reactants and products in a reaction. 382 is reactants and products, molecules of each of those, moles of each of those, relative mass of each of those, volume of gases. And then if you want to draw me something like this, I'll give you a bonus point, because I felt like dimensional analysis should make the test to say dimensional analysis looks like this, with stuff getting canceled every which way. Draw me a little picture like that and say dimensional analysis looks like that. Free point for you if you remember that that existed. 387 is a reactant that's not completely used up. 388 is a reactant that is completely used up. 389 is the product that is obtained. 390 is the product that's expected. Bonus point, if you tell me the theoretical is less and name me 4 reasons. Can anybody name me a reason why the theoretical turns out less?
Side reactions.
Side reactions.
Using some research containers.
Transferring container to container. An I word. And a P word. Isolation and purification. So bonus point around that 390 zone to say theoreticals last because of side reactions, isolation, purification, and transferring from container to container. Nice little list for you, just like Walt Whitman above the list. 390 we just did. 391 is the actual divided by the theoretical times 100. 392 is exothermic, heat is given off, and endothermic, heat is absorbed. 396, kinetic theory says heat and motion are related. All particles of matter are in motion to some degree, and heat is an indication of that motion. Bonus point, kinetic energy would like to break things apart. Attractive forces hold things together. You don't have to keep writing what I'm saying, but sometimes they each get their win. But kinetic energy is trying to break stuff apart. Attractive forces hold things together. 399, gas is composed of molecules is a phrase I'm about to say 4 times. Gas is composed of molecules, follow up, most of the volume is empty space. There's no attractive forces of molecules. There's constant rapid motion of molecules. There's perfectly elastic collisions of molecules. There's my 4. Follow up there, there's no kinetic energy lost. And then the 5th one is average kinetic energy is proportional to Kelvin temperature. 406, expansion, magic word is fill. Expansion fills all the space in which it's placed. Indefinite shape and volume, magic word is fits. Fits any vessel. Somebody asked me, don't those words mean the same thing? And I said, no. For example, any one of you individual people, you fit in this room. You do not fill this room. Those are 2 different words. Compressibility, a large volume can fit into a pressurized tank. Low density, we measure with grams per liter. Solids and liquids, in contrast, you measure with grams per milliliter. Last one was mixing. Bonus point somewhere in the 399 or 406 zone, somewhere in this area. Ideal gases conform to those assumptions. Real gases don't, but especially at high pressure, low temperature. So I'll run that back. Bonus point in that zone somewhere. Ideal gases conform to those assumptions. Real gases don't, but especially they don't at high pressure or low temperature. 415 is collision of molecules. 416 is our same list. I'll give you the same bonus stuff that we did on the test when we did this not long ago. 1 ATM makes the list. 14.7 PSIs. 760 mmHg. 76 CMHg. 760 torr. 1.013 times 10 to the 5th pascals. 1013 MBAR for millibars, 29.9 inches HG. And then if you tell me car tires have an average PSI of 32, car tire average 32 PSI, give you a bonus point for that. Turning the page, 422, we've got Boyle's Law is P1V1 equals P2V2. I didn't make you do the sentence, and you're welcome. Charles' Law, V1 over T1 equals V2 over T2. Gay-Lussac's Law, P1 over T1 equals P2 over T2. Those fraction ones, you could write them other ways. I could verify them if you want to ask me a question in a minute. 428 is 0. 429 is P1V1 over T1 equals P2V2 over T2. 430, ideal gas, and then PV equals nRT. And then I'm going to just finish the rest of this sheet, even though it doesn't apply to your life, so feel free to get your daydream on for a second. But just to have a complete video now while I'm making a video, I might as well just roll through the ones that we're not doing yet, because we're not to that chapter yet this year. But 432 for people in the future watching this video who care beyond 2024. 432, they're closer. There's some attractive forces, and the collisions are not perfectly elastic. 435 is limited expansion, indefinite shape. They maintain their volume. They're slightly compressible. They have high density, and they're slower mixing. 241 is the escape of molecules from the surface of a liquid to form a gas. 442 is a gas becoming a liquid. 443 is a high altitude. 444 is purifying water by boiling it and then collecting the vapor to cool. 445 is the property of a liquid to draw the surface molecules into the body of the liquid and minimize the surface. 446 is the resistance of a liquid to flow, sort of like inertia, but for liquids. 447, they're closest together, as opposed to 432, I said closer. 447, I'm upping it to closest. I'm going to say strong attractive forces this time. As opposed to 432, I said some attractive force. Now I'm saying strong attractive force. And then it's going to be fixed positions. 450's group is like 435's group, but the words get, again, stronger in their description. So there's no expansion. There's a definite shape. They still maintain volume, same answer. They're incompressible, not compressible at all. High density is the same. And then extremely slow mixing as everything gets a stronger description. 446 is a direct conversion of a solid into a vapor. Anybody in the room, this isn't a chapter you did, but do you know of something that turns from a solid to a gas directly in your life experiences?
From a solid to a gas?
Solid straight into a gas from life experience.
Oh, I don't remember. I know you're talking about.
Give you a hint, it's cold.
Ice? Dry ice.
Dry ice. Dry ice is like a solid block of ice, and they use it in plays and stuff because it creates sometimes a scene that looks like smoke or mist, or like it turns straight into a gas. There's no liquid. Penn State uses that to freeze ice cream if you want to take ice cream home for the creamery. They give you some dry ice and you bring it home and keeps your ice cream cold. Deposition, 457 is turning a vapor into a solid. 458, go out with an easy question, a big old no. That's it.